All right, here's that promised look at half-life and doubling time, things that exponentially grow or decay in known intervals where they double in a certain period of time or they halve over a certain period of time. So the first one we'll look at is half-life. If the setup for a half-life function is that what's being raised to an exponent is 1/2 itself. It's saying repeatedly you're taking half of the population, so half to some exponent kt means you're going to do half to, a third means doing a half multiplied 3 times, taking half of something 3 times, one after another. So we did this with the M&Ms when we did the decay. We rolled the M&Ms and then removed the ones with the M's up. That was actually a half-life scenario because basically we moved half over and over and over again. So now what we got is, here's the scenario. There's the variables that are in play are your initial value. You're given a measure of some time, it can be days, weeks, years, whatever it is. Then a constant k that has to do with that rate, how often that thing is halved. So the pieces you have to take into account, k, p naught, and t time are all present there. Now you have to find out, given that it halves every, 20 days in this situation, and it starts with 8 units, those are the things you're always going to be given, how much you start with and how fast it halves or doubles. The way we use it is take the initial amount, the half, of course, and then the k is the part we're going to find. That actually has to do with how fast this thing halves. We know that you'll get a 4, which is half of 8, the initial amount, after 20 days, when time equals 20. So you can put in that initial, after 20 days you'll have 4 in there, and you can use that to solve for k. So as we go through the rest of that algebra there, here's one way to do that. Divide both sides by 8. You get half equals half 20k. If you want to solve for an exponent like that, you do logs. That's one way. Both sides, bring out the 20k. And then from there, you're going to divide by the natural log of 1/2. Both sides, those are the same, so they'll cancel to 1. And then divide by 20 to find your k. So 1/20th. You may notice a pattern in here where you can do that a lot faster, find that k value. If you can, go with it, run with it. More power to you. That's the function we'll use for any half-life questions you may be given after this, like, what's how much in the population after 15 days, and you can find out how much in the population after 100 days. So you can plug in those t values as necessary, or you can say, when will the population reach 1? You can use that. You can set the whole thing equal to 1 and solve that. Next is doubling time. If you want to double something, the setup is 2 to the kt. You're taking a population and doubling it repeatedly, however much the exponent kt tells you. So doubling every time looks kind of like the inverse of halving. Hopefully it all looks real similar to you. The process is similar. If I want to know it doubles every 5 years, you have to know that, how often it doubles, and you have to know how much to start with. So 7 units. So we set this up the same way we did last time. Start with 7. It's a doubling formula, so 2 in parentheses. 5 every 5 years, so our time unit is years. You're going to see the population double to 14, so I can put in 5 and 14, and then solve by dividing both sides by 7. 2 equals 2 to the 5k. You can either do logs, like I'm going to do here, like we did last time, pull out the 5k, divide by 5, and get k equals 1/5. Or you can recognize that that's 2 to the first equals 2 to the 5k. That means that 5k has to be 1. You just recognize for those to be equal, the exponents have to be the same, and you can get k that way. Or you may notice some other shortcut, which if you're seeing a shortcut to this, you run with it because you're probably right. All right, there's your function that we can work with. We can answer questions like, when is the population 100, by setting it equal to 100, or when after 10 years, what will the population be? Put 10 in for t. That's it. Anything else, just send me a quick email and let me know, but that should get you through those doubling and half-life problems.